Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University. School of Agriculture, SOA. Diploma Postgraduate Diploma Programs. Diploma in Production of Value-Added Products from Cereals, Pulses and Oilseeds, Block-1. BPVI 031 Food Fundamentals. Block-1 Post-Harvest Management. Unit-1 Importance of Post-Harvest Management. 1.0 Objectives. Dash 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 dash. After going through this unit, you should be able to times learn the importance of post-harvest management of food grains, times understand the extent of post-harvest losses in food grains, times explain the role of temperature and moisture in post-harvest management, times know the availability of food grains and nutritional security, times know how the efficient and scientific post-harvest management can generate employment, times explain how value addition can increase their shelf life and merchantability of food grains, times know the benefits of efficient post-harvest management. 1.1 Introduction. The management of harvesting, threshing, cleaning, drying, storage and marketing of food grains up to consumption is known as post-harvest management. Efficient and scientific post-harvest management involves use of improved techniques of harvesting, threshing, cleaning, drying, storage, and transportation of food grains so as to minimize losses. Efforts made in increasing the agriculture production are nullified due to loss of crops due to inappropriate and inefficient post-harvest management. Scientific post-harvest management provides food security to the country and community and ensures availability of food grains until the next harvest. In developing countries like India where production is not stable and depends on monsoon, continuous efforts should be made to develop efficient and scientific post-harvest technology so post-harvest losses in food grains are minimized. In our country, about 10% of the food grains are damaged during post-harvest handling, which includes losses in harvesting, threshing, processing, storage and transportation. Moisture and temperature are two physical factors which cause considerable losses in food grains. Among the biological agents, insects, rodents, birds, bacteria, fungi are the main causes of food damage. About 6.5% food grains are lost due to biotic factors. Well-matured, clean and dry grains can be stored for longer time in scientific storage godowns, silos, storage structures like metal bins, reinforced cement and concrete RCC bins, pakka kotis, etc. On the other hand, immature and moist grains containing more than 16 to 18% moisture and having excess of foreign matter are easily damaged during storage. Higher moisture in grain attracts the insects and molds, which further degrade the quality and quantity of grains. Storage fungi rarely attack on dry grains. Proper and timely aeration of warm grain reduces its temperature and similarly, drying of moist grain reduces its moisture and makes it conducive for storage. Storage fungi or molds like Aspergillus flavus and Penicillium species not only damage the food grains completely but also produce certain mycotoxins in the food grains which are toxic for humans and animals. Aflatoxin is one of such mycotoxins produced by the Aspergillus flavus in high moisture paddy, rice, corn, and groundnuts. Aflatoxin contaminated grain is not fit even for animal feeds. A Maximum permissible limit of 30 ppb, parts per billion, of mycotoxin has been prescribed in food grains under Prevention of Food Adulteration Act, PFA. Harvesting of food grains at proper moisture is very important. If paddy is allowed to dry in the field, a high percent of shading of paddy kernels takes place. 1.2 Role of temperature and moisture in post-harvest management. Temperature. Temperature plays a very important role in safe storage of food grains. Warm and happy smiley. Moist grain deteriorates very rapidly during storage in a grain bin. Condensation of moisture takes place on top layer of grain when there is variation in inside and outside temperature of a grain bin. Aeration, which involves forced or natural circulation of ambient air in a grain mass, is widely used for reducing the grain temperature. Therefore, the temperature of a grain bin should be regularly monitored. Thermone samplers and thermone couples are used to monitor the temperature of a grain bin. There should not be more than 5 degrees Celsius difference between the temperature of grain in a bin and outside atmosphere temperature. Modern silos are equipped with inbuilt aeration system. The grain should be properly cooled before storage in a bin or any other storage structure. Moisture. Moisture plays a very important role in safe storage of food grains. High moisture deteriorates the food grains rapidly during storage. Discoloration of food grains, particularly in rice during storage, is due to the presence of high moisture. Besides, the high moisture attracts the insects and mold to further damage the food grains. On the other hand, low or safe moisture increases the storability of food grains and checks the growth of insects and molds. Therefore, measurement of correct moisture of food grains before storage is very important. Electronic portable moisture meters are available for the measurement of moisture content of food grains. Moisture is also very important in rice milling. Paddy should have optimum moisture content, about 14.5%, at a time of milling. High moisture paddy or very low moisture paddy results in high percentage of broken rice grains. Mechanical dryers are used for drying of paddy in the modern rice mills. Sun drying of paddy also results in excessive broken grain during rice milling. Therefore, the paddy should be dried under shed with continuous turning by foot or other means. The safe moisture of some food grains is given below. Table 1. Safe moisture upper limit of various commodities. Commodity and moisture content, percent wet basis. 1. Paddy, rice, raw, 14%. 2. Rice, parboiled, 15%. 3. Bengal gram 12%. 4. Wheat, sorghum, maj, barley, bajra, ragi, wheat atta and besan 12.5%. 5. Groundnut in pods 6 to 7%. 6. Mustard seeds 5 to 6%. From the table 1, it is known that paddy and raw rice can be safely stored at 14% moisture content and parboiled rice may be stored safely at 15% moisture content. Wheat and wheat products and other coarse grains like sorghum, maj, barley and bajra may be stored safely at about 12.5% moisture content. 1.3 Stored grain insect pests and their control. Stored grain insect pests cause both quantitative and qualitative losses during storage of food grains. At high moisture their growth and multiplication is very fast. The optimum conditions of temperature and relative humidity for the rapid growth and Multiplication of stored grain. Insect pests range from 25 to 35 degrees Celsius and 60 to 65% respectively. Stored grain. Insect pests also contaminate the food grains with harmful and unhygienic materials like uric acid, which causes rheumatic pain in human beings. The crawling insect infestation in the warehouse godowns may be controlled by spraying effective prophylactic chemicals such as malathion 50% EC, deltamethrin 2.5% WP at recommended doses on walls, floor, alleyways and surface grain bags. Malathion 50% EC may be diluted with water in the ratio of 1:131. Emulsion may be sprayed on 100 SQ MTR surface area after 15 days interval. Similarly, 40 grams of deltamethrin 2.5% WP ENI be dissolved in 1 liter of water, and 3 liters emulsion may be sprayed on 100 SQ MTR surface area after 90 days. The insects may also be eliminated by using fumigants like methyl bromide and aluminium phosphide, phosphine, at recommended doses in a closed airtight storage system or under gas-proof fumigation covers. The food grains should be properly aerated after fumigation, and brushing of grain bags should be carried out to remove the residue of aluminium hydroxide. 1.4 Food availability. The food availability is directly related to food production. Despite the continuous growth of population, the food availability has not changed much. During 1955, the per capita food availability was 157 kilograms per annum. Cereals, which had increased up to 167 kilograms per annum in 1995. The data from 1997 onwards shows that per capita net availability of cereals is decreasing. Table 2. The food grain production has also decreased during this period. The reasons for less food availability are I. Deficit of food production over consumption. 2. Instability in cereal production. IGNOU of people states affected by flood, drought and other natural calamities. States like Punjab, Haryana, western part of UP, where the cereal production has increased considerably and there is surplus availability of food grains as well as stability in cereal production, have abundant food availability. These states are also not generally affected by flood, drought and other natural calamities. On the other hand, Gujarat, Rajasthan and Bihar are food insecure states in terms of food grain availability because cereal production has not shown much increase in these states. Besides, there is instability in cereal production and these states are generally prone to drought, floods and other natural calamities. 1.5 Nutritional security. Cereals, wheat, rice, maize, barley and sorghum continue to be the most important source of nutrients. According to the food balance sheet, cereals currently supply 59.0% of total calories, 58% of total protein and 13% of total fats. However, data collected by National Sample Survey (NSS) indicate that cereals provide about 65% of protein. In India, cereals are much cheaper source of nutrition. The poorer population in our country get much larger calories from cereals, which was about 75% for the 40% bottom line population INI 999-2000. It has been observed that diversification away from cereals increases the cost per unit of nutrient intake and corresponding increase in calorie and protein is less than increase in food expenditure. Thus, cereals contribute nutrient intake. Food balance. Sheet shows larger improvement in per capita calories availability rising from 2000 kcal during 1970s to 2200 kcal in 1980s and 2400 kcal in 1989. Efficient public distribution system. Food grains has played an important role in meeting average nutritional requirements. The state-wise nutritional availability for the year 1999 to 2000 is given below. Table 3, state-wise nutritional availability for the year 1999 to 2000. Name of the state, their per capita cereal output in kg year, and per capita nutritional, total calories, intake in kcal day. 1 Andhra Pradesh 166-2021. 2 Assam 139-1960. 3 Bihar 125-2121. 4 Gujarat 92-1986. 5 Haryana 582-2455. 6 Himachal Pradesh 213-2454. 7 Kamtaka 167-2028. 8 Kerala 24-1982. 9 Madhya Pradesh 198-2062. 10 Maharashtra 104-2012. 11 Odisha 159-2119. 12 Punjab 969-2381. 13 Rajasthan 193-2425. 14 Tamil Nadu 139-1826. 15 Uttar Pradesh 235-2327. 16 West Bengal 183 2095. From the table 3, it is inferred that Assam, Gujarat, Kerala and Tamil Nadu were having lower per capita total calorie intake than the average national calorie intake of 2000 kilocalories per day. It is also observed that per capita cereal output in these states was also lower. Therefore, calorie intake is directly related to cereal output. Continuous efforts should be made to increase the food grain production in these states so that the per capita total calorie intake may be increased. 1.6 Employment generation. A large number of young people in the villages in our country are unemployed. There is a need that these people should be provided employment in their villages. Itself a well-planned and efficient post-harvest management strategy may provide employment to large number of such people. These people in rural areas may be employed in construction of small rural godowns for the storage of food grains. The small godowns may also be maintained and operated by educated and trained young people in the villages. Small-scale paddy processing units, paddy parboiling plants, dal or pulse mills may provide employment to rural unemployed people. Rural artisans may be imparted training in construction of scientific grain storage structures like metal bins, pakka khoshes, RCC bins. Government of India through Ministry of Rural Development has initiated Sampurna Gramin Rozgar Yojana, SGRY, on 15 September 2001 to provide employment in rural areas. The people are engaged in creation of infrastructure facilities in villages such as construction of roads, ponds, rivers and houses. The scheme has cash and food grain components and the central government bears 75% and 100% cost of the two components respectively, and balance is borne by the state governments and UTs. In May 2004, 82.23 crores man days were generated and central government has released 4,496 rupees crores cash and 50 lakh tonnes of food grains to state and UTs. Besides, under special component of SGRY, the central government has released 26 lakh tonnes of food grains to 13 drought-affected states. In 2005 to 2006, up to November 2005, 48.75 crores man-days were generated and the Government of India has contributed 4,651 rupees crores and 35 lakh tons of food grains. 1.7 Value addition. Post-harvest losses in food grains have been reported to be about 10%. In some of the developing countries, these post-harvest losses are much higher. The various factors contributing post-harvest losses in food grains are moisture, temperature, insects, microorganisms, fungi, and rodents. The losses are caused during harvesting, threshing, processing, storage, transportation, and marketing. One of the important methods to minimize these post-harvest losses in food grains is to increase local value-added food products by developing rural agro-industries in the producing areas. These agro-industries may be developed and managed at community level. Processing of food items in a form which has a longer shelf life, better merchantability, and thus adding value to the original crop helps the farmers and growers in reducing spoilage and post-harvest losses. Besides, the value-added products fetch more price and can be safely transported to long-distance urban and semi-urban markets. These value-added products have also good prospects for export. Production of peanut butter, flour meal, papad, noodles, corn flakes, puffed and beaten rice are some of the areas which are very useful for farmers as well as traders. The production of semi-processed food products may also be explored. The government and semi-government organizations provide technology, training, as well as marketing facilities for such value-added products. Thus, value addition of agricultural produce in the producing areas is one of the most efficient methods of post-harvest management. 1.8 Exports. Indian basmati rice is in great demand in USA, UK and Gulf countries. At present, India is not having surplus wheat and the country is importing wheat from some countries. However, the economists and agriculture scientists are oft view that due to the continuous efforts made by the farmers and the government, the production of wheat would increase sufficiently in future and India would be one of the major wheat exporting countries. Quality-wise, Indian wheat is similar to Australian wheat. Strict quarantine, arid pesticide residues are some of the impediment which discourages the export of food grains and their milled products. There is a great demand of organic food grains, like basmati rice and durum wheat in Europe and America, which are grown without the use of chemicals and fertilizers. Some of the Indian farmers in Punjab, Haryana, and Uttaranchal have started producing such organic food grains. Ministry of Commerce had set up Agricultural and Processed Food Products Export Development Authority, APEDA, with a view to promote export of agricultural products as well as processed food items. The authority provides information about foreign markets where there is demand of Indian basmati rice and other food grains. The authority also provides information about the quarantine and pesticide residues standards prevalent in those countries. Some of the Indian laboratories have been authorized to carry out these tests for export purposes for the benefit of exporters. A number of private Indian companies, including joint venture, have set up their own production and processing centers for the export of Indian basmati rice, semi-processed basmati rice, brown rice, without polishing, is also exported to DK and some other European countries. From India, some of the countries like UK provide subsidy on import of such semi-processed food items. 1.9 Rural industrialization. Scientific and well-planned post-harvest management of food grains has vast scope for rural industrialization. There are no proper and scientific storage facilities for food grains at farm level in the producing areas except in few states like Punjab and Haryana. Therefore, scientific rural godowns, individual and community level rural storage structures should be developed in the rural areas. Government of India has launched a scheme wherein individuals, unemployed youths, cooperative sectors are provided subsidy for construction of rural godowns and cold stores. Considerable storage capacity has been created under TILS scheme. Large number of unemployed youth have got employment in construction of these storage structures. Further, employed youths, after proper training, may be deployed in maintenance and operation of these small rural godowns. Similarly, small rice mills, dal mills, parboiling plants, puffed rice and beaten rice plants may be set up in rural areas with the financial assistance of banks, cooperative societies and other organizations. Ministry of Food Processing Industries, Ministry of Agro Industries and Ministry of Agriculture provide technical training and incentives for setting these agro-based industries. The state governments also provide financial and technical assistance to unemployed rural youths to set up such industries in the villages. These rural industries may solve the problem of unemployment in villages, and migration of rural population to urban areas may be checked. Keeping in view the importance of agro-industries, the Government of India has set up a separate agro-industries ministry. 1.10 Benefits of PQST harvest management. Efficient post-harvest management involves using improved and scientific technique in harvesting, threshing, cleaning, grading, processing, handling, storage, transportation and marketing of food grains. High temperature during storage, high moisture content, insects and fungal infestation and damage during handling, packaging, storage, and transportation are the main causes of post-harvest losses in food grains and other agricultural produce. Stored grain insect pests also cause quantitative and qualitative losses in food grains during storage. The benefits of an integrated efficient post-harvest management are as follows. I. Storage and transit losses in food grains and their milled products are reduced. It. Storability of food grains is increased. 3. Quality of the food grains and their milled products is maintained. 4. Farmers, growers, traders get higher market price of their agricultural produce. Availability of food grains and milled products is increased. 6. Post-harvest operations including value addition generates employment in the rural and semi-rural areas. 7. Merchantability of the food grains and milled products is increased. 8. Efficient post-harvest management provides food security. 9. Nutritional requirement of population from cereals and pulses are met. Smiley surplus food grains may be exported which can aim foreign exchange required to import advanced technology. 11. The farmers' growers may store their food grains in scientific godowns, warehouse at time of glut in the market and sell them in the off-season at higher prices. 1.11 Summary. Efficient and appropriate post-harvest management involves use of improved and scientific code of practices in handling, grading, drying, processing and storage and transportation of food grains. Considerable losses are caused in food grains due to inefficient post-harvest management. The post-harvest losses in food grain have been estimated to be about 10%. Temperature, moisture, insects, rodents, birds and molds are main causes of post-harvest losses in food grains. Temperature may be reduced by aeration of food grains and high moisture may be reduced by drying techniques. Stored grain insect pests which cause both quantitative and qualitative losses may be controlled by using effective prophylactic chemicals such as malathion 50% EC, deltamethrin 2.5% WP and fumigants like methyl bromide and aluminium phosphide, phosphine, at recommended doses. The treated grain should be properly aerated after fumigation and cleaning of grain bags should be carried out to remove the residual part of fumigant. The processed food items may be transported safely to long distances urban markets. Besides, their shelf life and merchantability are increased and farmers growers get better price of their produces. High quality value added food grains may also be exported. The farmers can store their food grains in scientific godowns and warehouse set up in the rural areas at the time of glut in the markets and sell them in the off-season when prices are higher. An integrated efficient post-harvest management has several benefits such as storage and transit losses are minimized, storability is increased, quality of food grains and their milled products is maintained, their merchantability is increased, farmers, traders get higher market price of their agricultural produce and availability of food grains and milled products is increased. Besides, value addition of food grains, cereals and pulses generates employment in the rural and semi-rural areas. The most important advantage is that efficient post-harvest management provides food security and nutritional requirements. By exporting surplus food grains and milled products, foreign exchange may be earned. The Indian basmati rice is in great demand in UK, Europe and several Gulf countries. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.